Hello and welcome to Science Night Tales. I am glad you have found this quiet moment to pause. Tonight we are going to challenge the feeling of solidity beneath your feet. We often assume that the Earth, this vast, stable rock we call home, was inevitable, that it was always meant to be here. But if we wind the clock back far enough, we find a time when this planet was not a promise, but a gamble. We are going to travel back 4.5 billion years to the Hadean Eon, a time of fire, dust and uncertainty. We will explore the violent, fragile history of how scattered dust struggled to become a world, and how the stability we rely on today was forged through a long series of near misses. You do not need to worry about the chaos of the past tonight. The ground has cooled, the atmosphere is holding, and you are safe. You can simply let the scale of time wash over you. If this perspective helps you find a sense of calm in the vastness of history, you are welcome to like or subscribe. For now, let go of the present and let's drift back to the very beginning. For a long time, it feels natural to assume that Earth was always meant to be here, that this planet was a stable outcome, that its presence was guaranteed once the sun formed, that the ground beneath you was always part of the plan. But if you move backward far enough in time, before continents, before oceans, before even a solid surface existed, that assumption quietly falls apart. There was a long period when Earth did not yet exist as a planet. There was no clear boundary, no defined shape, no lasting structure, only scattered material moving through the early solar system, without coordination, without permanence. At that stage, nothing required these materials to remain together. Nothing required them to grow. Nothing required them to become a planet at all. The outcome was still open, the conditions were unstable, so the process was incomplete and continuation was not guaranteed. What would later become? Earth began as a collection of solid particles mixed among countless others, all sharing the same region of space. Some of this material passed nearby and continued onward. Some briefly clustered, then separated again. Retention was uncertain. Loss was common. At any moment, growth could stop. Material could drift away faster than it accumulated. Energy could escape instead of remaining trapped. Structure could fail to appear. There was no signal that this process would succeed. Even as accumulation slowly increased, it did not produce stability. Increased mass did not mean permanence. In many cases, it meant greater exposure to disruption. Larger bodies experienced stronger heating. Stronger heating increased internal stress. For internal stress introduced new ways for progress to reverse. Nothing about size alone ensured survival. Heat, which would later be essential for internal organization, was also a threat. If too much energy escaped too quickly, internal processes could stall. If too much energy remained, material could lose coherence. Balance was required, but balance was rare. At this stage, Earth was not a planet. It was a developing system with no assurance of completion. There were periods when growth slowed, periods when accumulation nearly stopped, periods when loss outpaced gain. Each of these moments represented a possible ending. If enough material failed to remain bound, the process would not restart. If internal heating diminished too early, differentiation would not proceed. If structural coherence never emerged, there would be no long-term evolution, and none of these outcomes would have been unusual. Across the early solar system, many similar processes began and ended without producing stable planets. Some never grew beyond scattered material. Others reached partial formation before breaking apart or remaining incomplete. Earth was not exempt from these possibilities. During its earliest stages, it occupied the same uncertain category. Development depended on narrow conditions that did not announce themselves in advance. There was no clear threshold where failure became impossible. There was no moment when continuation was secured. Only gradual change, followed by long pauses. Only small advances, followed by renewed uncertainty. Internal changes began slowly, but they were not final. Early differentiation could reverse. Partial organization could be undone. Progress could reset without warning. Each step forward remained provisional. The system did not know where it was going. It did not move toward an outcome. It simply responded to physical conditions as they unfolded. At several points, retention itself was at risk. At several points, internal heat could have dissipated too quickly. At several points, accumulated material could have been redistributed. None of these outcomes would have been dramatic. They would have been quiet. They would have gone unnoticed, and they would have ended the process completely. From the perspective of the present, it is tempting to see continuity, to imagine a smooth progression from early material to finished planet. But that continuity only appears when viewed in reverse. In real time, the process was uneven, interrupted, frequently unstable. Earth did not move steadily toward completion. It hovered repeatedly between continuation and collapse. There was no stable surface, no persistent interior structure, no long-term environment, only temporary arrangements that could dissolve. The system existed in a state of ongoing uncertainty, where each phase depended on conditions that could shift without warning. At no point during this early period could the outcome be predicted. At no point could success be assumed. Even when Earth began to retain more mass than it lost, that balance remained fragile. Minor changes in surrounding conditions could still alter the trajectory. Growth did not eliminate vulnerability. In many ways, it increased it. As the developing body became more complex, there were more ways for that complexity to fail, more internal processes to interrupt, more energy exchanges to misalign, more opportunities for progress to stall. Nothing about this stage resembled inevitability. Nothing suggested permanence. If the process had ended here, there would be no record of it. No surface to examine, no atmosphere to preserve traces. The materials would simply disperse, becoming part of the background again. And the absence of Earth would not stand out. It would be normal. This is the part that often goes unnoticed. The fact that non-formation is the default outcome. The fact that continuation is the exception. The fact that stability must be achieved, not assumed. During this long interval, Earth was not yet a planet waiting to emerge. It was a system still deciding whether emergence would happen at all. Every stage remained conditional, yet every advance remained reversible. There was no clear signal that this process would cross the threshold into permanence. No moment when the future became fixed, only a series of temporary states, each one unresolved. From here, it becomes necessary to ask a question. Not how Earth formed, but how it managed to continue. How development proceeded when so many opportunities for failure remained present. How structure began to persist instead of dissolving. Because at this point in time, nothing had been settled yet. The planet was not complete, it was not secure, it was still undecided. This undecided state was not a brief pause. It lasted for hundreds of millions of years, a period now known as the Hadean Eon. Beginning approximately 4.54 billion years ago, this was a time defined not by the presence of a world, but by the violent and slow-motion assembly of one. To look back at this window is to see time at a scale that defies human experience, where temporary lasted for eons, and where the transition from scattered dust to a cohesive sphere was a struggle measured in hundreds of millions of orbits around a young, faint sun. Material was present long before a planet existed, not arranged, not organized, not committed to becoming anything lasting. In the early solar system, solid particles moved through shared space, following paths shaped by gravity and motion, but not by intention. These particles varied in size, composition, and temperature. Some were small and transient, others were larger, but still incomplete. None of them carried any guarantee of persistence. At this stage, what would later become Earth was not distinct from its surroundings. It did not stand out, it did not yet hold a boundary. Solid material occupied the same region as countless other fragments, all moving, separating, and occasionally passing near one another. Proximity did not imply connection. Contact did not imply permanence. When particles came together, the connection was often temporary. Motion continued, paths crossed, separation followed. Accumulation was not continuous. It occurred in brief intervals, interrupted by longer periods of dispersion. Material gathered slowly, then spread again. There was no steady trend toward growth, only fluctuations around balance. In many cases, material that approached simply moved past and continued onward. Retention was uncertain. For accumulation to proceed, material had to remain nearby long enough for repeated interactions to occur. But the early solar system was an active environment. Motion was constant, disturbance was common, stability was rare. Small changes in velocity were enough to prevent long-term gathering. Small changes in direction were enough to scatter material again. Nothing in these conditions favored persistence. Even when particles clustered, the resulting structures were weak. They lacked internal coherence. They lacked the mass required to dominate their surroundings. Any organization that formed could be undone by the next encounter. At this point, there was no single body acting as a center. There was no surface, no interior, no defining shape. Only a region where material sometimes lingered longer than elsewhere. This is where the process could have ended. If dispersion had continued to dominate over retention, accumulation would have stalled. If interactions remained brief and infrequent, no long-term structure would have emerged. If material failed to remain bound, development would not resume later. There was no reset. There was no second chance. The early phase of accumulation did not move forward because it was destined to. It moved forward only when local conditions briefly allowed it to. When material remained closed long enough, mass increased slightly. When mass increased slightly, interactions became more frequent. But this did not create security. Increased mass also meant increased exposure. Larger groupings experienced stronger interactions with surrounding material. They encountered more frequent disturbances. They absorbed more energy. Each gain introduced new ways to lose what had been gathered. Growth did not eliminate vulnerability, it amplified it. At several points, accumulation nearly stopped. At several points, loss nearly exceeded gain. These moments were not dramatic. They did not announce themselves. They passed quietly, leaving only the possibility that development might not continue. From the present, it is easy to imagine this phase as the beginning of something. But from within the process, there was no indication that continuation would follow. There was no stable reference point, no threshold that once crossed ensured success, only repeated attempts at coherence. Some regions in the early solar system experienced similar accumulation, only to lose it again. Some gathered material temporarily and then dispersed entirely. These outcomes were common. They were not unusual failures. They were expected results of unstable conditions. Earth occupied the same category during this phase. Its material was not protected from loss. Its accumulation was not privileged. What allowed growth to proceed was not strength, but timing. Occasionally, conditions aligned just long enough for material to remain nearby. When that happened, mass increased incrementally. Each increase slightly altered the local environment, changing how future interactions unfolded. But these changes were subtle. They did not remove risk. At no point during this phase could accumulation be assumed to continue. Even after repeated interactions, structures remained loosely bound. They could still separate, they could still fragment, they could still lose material faster than it was gained. The difference between continuation and collapse remained narrow. Throughout this stage, the process advanced slowly, unevenly, without direction. There was no clear progression, only a series of temporary states that sometimes lasted longer than before. Each of these states depended on conditions that could shift at any time. This is what made early accumulation fragile, not because growth was impossible, but because it was reversible. Every gain existed alongside the possibility of immediate loss. Every brief period of retention existed alongside countless ways for material to disperse again. Nothing had been secured. Nothing had been stabilized. What existed was only potential, held briefly in place by circumstances that did not persist. And yet, accumulation did continue. Not smoothly, not consistently, but enough to move into the next stage. Still, at this point, the system remained exposed. Exposed to motion, exposed to disturbance, exposed to reversal. The early accumulation of material did not mark the beginning of a planet. It marked the first moment when non-formation was no longer the only outcome. That distinction was subtle, and it could still be undone. As this phase came to a close, nothing resembled stability yet. Mass had increased, but coherence had not followed. Structure remained incomplete. Development remained provisional. What existed was more than before, but not enough to endure. And that uncertainty did not disappear. It carried forward into the next stage, where growth continued, but with new risks and no promise that it would last. Growth continued, but stability did not arrive with it. Material kept accumulating, slowly increasing the overall mass of the forming body. Each collision added substance. Each close encounter altered motion just enough to draw more material inward over time. From a distance, it might have appeared as progress, but increased size did not simplify the system, it complicated it. As mass grew, gravitational influence strengthened. More material was drawn in, but that same gravity also increased internal stress. Forces that once acted gently now acted across larger volumes, amplifying small irregularities rather than smoothing them out. Growth introduced new conditions that had never existed before. Internal temperatures rose unevenly. Some regions warmed faster than others, depending on impact history, composition, and depth. Heat did not distribute uniformly. It collected, escaped, and reappeared in shifting patterns. There was no stable balance. With greater mass came stronger gravitational compression. Material deep inside experienced increasing pressure, but pressure alone did not guarantee structural coherence. Instead, it altered physical properties in ways that were still uncertain. Solid regions softened, viscous regions thickened, boundaries blurred. Growth did not lock the system into a clear trajectory. It widened the range of possible internal states. Rotation became more pronounced as mass increased. Angular momentum accumulated through oblique impacts and uneven accretion. Rotation influenced internal motion, but not predictably. Some rotational states encouraged internal circulation. Others interfered with it, redirecting energy into patterns that did not support long-term organization. Nothing synchronized. As size increased, so did exposure to disruption. A larger body presented a larger target. Encounters that might once have passed harmlessly now resulted in collisions. Each impact added material, but also added energy. The energy did not arrive gradually. It arrived suddenly, overwhelming local conditions. Heat spikes followed, shock waves propagated. Existing internal motion was disturbed. Growth and disruption became inseparable. The system did not grow first and destabilize later. Instability grew alongside mass, step by step. Retention of material was not guaranteed. Some collisions added mass, but others removed it. High-energy impacts could eject material back into surrounding space, undoing previous accumulation. There was no net assurance of increase. Even when mass remained, its distribution changed. Newly added material did not always integrate smoothly. It could remain chemically or thermally distinct, creating internal contrasts that added stress rather than cohesion. Growth introduced heterogeneity. Composition varied with depth and location. Some regions became enriched in heavier elements. Others remained dominated by lighter material. These differences influenced internal behavior in ways that were still reversible. Nothing settled permanently. Thermal gradients steepened as the interior warmed unevenly. Heat transfer mechanisms struggled to keep pace. Conduction, limited by material properties, could not equalize temperatures quickly. Convection, where it existed, remained incomplete and intermittent. Energy lingered longer than expected in some regions and escaped too quickly from others. This imbalance created vulnerability. If heat dissipated too rapidly overall, internal motion could stall. If heat accumulated too unevenly, internal stresses could fracture developing structures. Growth increased both risks simultaneously. The system now existed in a narrow zone between insufficient energy and excessive disruption. Remaining within that zone required conditions that were not enforced by any mechanism. Chance dominated. There was no safeguard ensuring that mass accumulation would continue smoothly. No threshold beyond which survival became automatic. Size did not protect the system from failure. In some scenarios, greater mass made failure more likely. Increased gravity intensified impacts. Increased heat complicated internal behavior. Increased rotation introduced additional instability. The forming body did not become calmer as it grew. It became more sensitive. Time extended these risks rather than resolving them. Over millions of years, cumulative effects compounded. Small imbalances persisted long enough to influence later conditions. A minor difference in heat retention early on could alter internal motion much later. A slight change in rotation could redirect material flow over extended periods. nothing reset cleanly. Growth did not erase earlier uncertainty. It preserved it, embedding it deeper within the system. From the outside, there was still no stable surface, no defining shape that could be called permanent. The body remained irregular, constantly reshaped by impacts and internal adjustment. From the inside, there was no fixed structure. Partial organization appeared and disappeared. Temporary layers formed and dissolved. Motion began and stopped without completing a full cycle. At no point during this phase did growth translate into security. Each increase in mass opened new possibilities, but also new failure modes. The system balanced continuously between continuation and collapse, without favoring either outcome. There was no moment where survival became likely, only moments where it remained possible. As mass increased further, the margin for error narrowed. Conditions had to remain within specific ranges for eternal processes to persist. Slight deviations could end development quietly without external signal. Cooling could outpace heating. Rotation could disrupt internal alignment. Impacts could remove more material than they added. All outcomes remained viable. The body existed, but only provisionally. Its future depended not on how large it became, but on whether its internal state could endure continued growth without unraveling. That question remained unanswered. Growth continued, but certainty did not. The system moved forward in size while remaining suspended in outcome. What followed would not depend on accumulation alone. It would depend on whether internal change could begin to persist rather than reset. And at this stage, there was no indication that it would. Internal change did not begin as a transformation, it began as a tendency. As mass slowly increased, conditions inside the growing body shifted, not decisively, but enough to allow new behaviors to emerge. Pressure rose unevenly. Temperature varied from region to region. Energy did not distribute itself smoothly. Nothing about this process was stable. The interior did not suddenly reorganize. It did not separate cleanly into layers. What occurred instead were partial adjustments, temporary differences forming and dissolving as conditions fluctuated. Some material warmed slightly more than its surroundings. Some regions became marginally denser. Some components responded differently to heat and pressure than others. These were not permanent changes. They were experiments imposed by physics, not commitments made by the system. When energy accumulated locally, heavier material tended to move inward. When energy dissipated, that movement could slow, stop, or reverse. Differentiation did not proceed in one direction. It hesitated. At times, internal motion increased. At times, it stalled. The interior existed in a state of incomplete sorting. Dense and less dense materials did not remain separated. They mixed again when conditions shifted. Boundaries formed briefly, then softened. This stage depended on narrow conditions. Too little heat and internal motion ceased. Too much disturbance and partial structures were erased. Too rapid a change and material lost coherence entirely. There was no margin for error. Internal differentiation required just enough energy to mobilize material, but not enough to destabilize the entire body. It required persistence without intensity, continuity without violence. Such conditions were rare. When they did occur, their effects were modest. A slight concentration of heavier elements toward the center. A slight redistribution of lighter material outward. A slight increase in internal complexity. None of this implied permanence. At any moment, interruption could undo the process. An external impact could remix material. A change in rotation could redistribute stress. A loss of heat could freeze motion in place before any pattern stabilized. Internal change did not accumulate reliably. It advanced in fragments, each dependent on the survival of the previous state. Even when differentiation progressed slightly further than before, it did not establish a stable configuration. It only altered probabilities. We had changed what might happen next, not what would happen. From the outside, nothing visible announced these changes. There was still no surface distinction, no clear internal architecture, no defined center that remained dominant. The body remained vulnerable. This stage is often described as the beginning of structure, but structure implies durability. What existed here was conditional organization, patterns that appeared only while specific conditions were maintained. The system did not move toward a final form. It explored a range of possibilities. Some internal arrangements lasted longer than others. Some dissolved quickly. Some reappeared after disappearing. None were guaranteed to persist. Differentiation did not reduce uncertainty. It redistributed it. As internal processes became more complex, the number of ways they could fail increased. Each new behavior introduced new dependencies. Each dependency introduced new fragility. The system became more interesting, but not more secure. Curiosity deepens here, not because something has succeeded, but because something has almost succeeded, without crossing the threshold into permanence. The interior was beginning to respond to itself, beginning to evolve internal feedback, beginning to exhibit behavior beyond simple accumulation. But beginning is the key word. Everything remained interruptible. At this point, development could still stall indefinitely. Partial differentiation could freeze in place and never resume. Internal motion could cease before any lasting pattern emerged. Many bodies in the early solar system reached this stage and went no further. They did not fail dramatically. They simply stopped changing. Earth had not yet distinguished itself from those outcomes. What it had gained was complexity, not destiny. The interior was experimenting with organization, but it had not committed to it. Nothing ensured that these internal processes would continue or intensify. Nothing protected them from being undone. As this phase drew on, internal change remained tentative, reversible, conditional, unfinished, and that incompleteness mattered because it meant that what followed would not build on a stable foundation, but on something still in flux, something that could still be erased by the next interruption. The next stage would not refine what already existed. It would test whether anything that had formed could survive disruption at all. Progress did not move forward in a straight line. It paused, it shifted, it was interrupted. After internal changes began to appear, they were repeatedly met by events that did not resolve anything. These were not climactic moments. They were interruptions, brief intrusions that altered conditions and then faded, leaving uncertainty behind. Impacts continued to occur, not as a single defining collision, but as a long sequence of encounters spread across immense time. Some were minor, others carried enough energy to affect the interior more deeply. None arrived with meaning attached to them. Among these encounters, one stood apart in its capacity to end the process entirely. Approximately 60 to 100 million years after the system began to gather, a Mars-sized body, often called Theia, collided with the proto-Earth. But this was not a mere interruption, it was a total mechanical reset. The energy released was sufficient to liquefy the entire surface, creating a global magma ocean and ejecting the material that would later condense into the moon. This moment represented the ultimate narrow margin. Had the angle of impact been more head-on, the proto-Earth might have been shattered beyond the reach of gravity's recovery. Had it been more glancing, the internal mixing required for a stable metallic core might never have completed. The system survived not by resisting the blow, but by absorbing its heat, using the resulting molten state to accelerate the very differentiation that had previously stalled. Each interruption added energy unevenly. Heat rose in some regions and declined in others. Motion increased briefly, then slowed again. The internal processes that had begun to organize material were disturbed before they could stabilize. Nothing inside was fixed. Partial differentiation softened. Temperature gradients shifted. Material that had started to move inward or outward lost momentum. What had formed was exposed again. These events did not erase everything at once. They worked gradually. They interfered with continuity. They ensured that no internal state lasted long enough to become secure. Time passed between interruptions. Long spans of relative quiet allowed some internal motion to resume. Heat redistributed slowly. Density differences reappeared in limited regions. For a while, processes seemed to continue. Then another disruption arrived. Conditions changed again. The system adjusted, not toward an end state, but toward whatever configuration could exist under the new constraints. Each interruption reshaped the range of what was possible. Development became conditional. Internal motion depended on remaining heat. Heat depended on timing. Timing depended on events beyond control. There was no steady accumulation of progress, only repeated exposure to change. As mass increased, the system gained inertia, but also vulnerability. A larger body retained energy longer, but it also attracted more impacts. Growth did not simplify conditions, it complicated them. Energy entered unpredictably. Sometimes it mobilized internal material, just enough for partial organization to resume. Sometimes it overwhelmed existing structure and erased it. Often it did both in different regions at the same time. The interior never aligned as a whole. From the outside, nothing signaled advancement. There was still no stable surface, no lasting boundary between inside and out. Only a body in motion, repeatedly altered by its surroundings. Millions of years passed this way, not as a build-up towards certainty, but as a sequence of trials without resolution. Each interruption tested whether any internal change could persist. Each one narrowed the conditions under which development might continue. Some internal patterns reappeared after disruption, others did not. The system did not preserve every path it explored. Uncertainty accumulated. Processes overlapped without completing. Heat declined, then was reintroduced unevenly. Motion slowed, then restarted out of sequence. No stage concluded cleanly. This was not escalation, it was repetition. Change, then pause. Formation, then disruption. Adjustment, then uncertainty, again and again. Time did not clarify the outcome, it extended the question. Could partial organization survive repeated interruption? Could internal processes persist without stable conditions? Could anything endure long enough to accumulate? There was still no answer. What existed remained provisional, always dependent on conditions that could shift without warning, always exposed to being undone. By the end of this phase, nothing had resolved. The body was more massive but not stable. Internal structure remained incomplete. The future remained undecided. What followed would not emerge from calm continuity. It would arise from disruption itself, not as an obstacle, but as a defining force. The events that once appeared only as interruptions can be seen differently now. Not as obstacles placed in the way of formation, but as conditions that reshaped what formation could become. The repeated disruptions did not simply pause development. They altered the internal balance in ways that slow, uninterrupted change could not achieve. Energy entered the system unevenly, not too little, not too much. Enough to keep internal material mobile, but not enough to dissolve everything that had already begun to organize. Timing mattered. If interruptions had arrived earlier, internal motion would have dispersed before any structure could emerge. If they had arrived later, partial organization might have locked into unstable configurations. Instead, disruption arrived while processes were still flexible. Heat was redistributed again and again. Each time, it softened regions that had begun to solidify. Each time, it prevented internal gradients from freezing too early. Motion was restored just enough to allow rearrangement, not erasure. This was not stability, it was conditional persistence. Internal differentiation did not advance in a straight direction. It oscillated, it paused, it resumed in altered forms. Each disruption adjusted the internal landscape, changing which pathways remained open. Some material moved inward more efficiently after repeated heating. Some regions lost energy more gradually as mass increased. Some internal boundaries became harder to undo, simply because conditions no longer allowed full reversal. Nothing was planned, nothing was protected. The system responded only to physical limits. As mass grew, gravity retained heat more effectively. As heat lingered longer, internal motion persisted. As motion persisted, differentiation became harder to erase completely. The disruption did not guarantee survival. It narrowed the range of outcomes. Too much energy would have undone everything. Too little would have ended motion altogether. What occurred stayed within a narrow window. Repeated impacts altered rotation. They redistributed angular momentum. They changed how material moved internally over long timescales. These changes were not dramatic at once. They accumulated quietly. Each interruption slightly modified the system's response to the next one. Earlier disruptions left the interior more resilient to later ones, not stronger but less reversible. Some internal arrangements, once disturbed and reformed multiple times, no longer returned to their earlier states. This was not progress toward an endpoint. It was the gradual loss of alternatives. With every disruption, some possible futures closed. Others remained. Heat sources became more internally sustained. Short-lived energy inputs overlapped with longer-term retention. Motion became less dependent on external events and more on internal balance. The same processes that once threatened to erase development now prevented premature stagnation. Without disruption, internal gradients could have collapsed into immobility. Without disruption, partial differentiation could have frozen into unstable layers. Without disruption, internal motion might have ended before it could persist. Instead, instability delayed finality. It extended the period during which internal processes could interact, rearrange, and adapt to changing conditions. This is not resilience in an emotional sense. It is persistence within limits. Survival was not achieved by avoiding danger. It occurred because danger remained within narrow bounds. Each near failure constrained the system without ending it. Each interruption tested whether internal processes could continue under altered conditions. Over time, the answer shifted. Not suddenly, not conclusively, but incrementally. Internal motion lasted longer after each disruption. Energy distribution became more even across deeper regions. Reversal became less complete. What once reset progress now reshaped it. The same uncertainty that defined the early stages did not disappear. It transformed. Instead of asking whether formation would continue at all, the system faced subtler questions. Which internal arrangements could persist? Which energy balances could be maintained? Which disruptions could be absorbed without collapse? The outcome remained undecided, but the range of outcomes had narrowed. This is where meaning begins to emerge, not as inevitability, not as success, but as survival constrained by physical precision. Existence did not arise because conditions were favorable. It arose because conditions were unstable in specific ways, at specific times, within specific limits. The early planet did not escape failure. It passed through it repeatedly, altered each time until failure became less complete. What follows builds on this realization. Because the defining features of Earth did not emerge despite disruption, they emerged through it. Long-term structure did not appear suddenly. It emerged only after the system passed through conditions that repeatedly disrupted any early attempt at permanence. For a long time, internal organization remained temporary. Layers formed, then softened. Boundaries appeared, then blurred. Motion persisted, but it did not yet settle into lasting patterns. Growth alone was not enough. Increasing mass raised internal pressure, but pressure without sustained heat led to rigidity. Heat without sufficient mass escaped too easily. Neither condition by itself could support long-term organization. What changed was not the presence of energy, but its duration. After repeated disruptions, internal heat was retained for longer intervals, not indefinitely. Just long enough for internal movement to continue between events rather than restart from zero. This persistence mattered. When internal motion lasted longer, material had time to respond differently. Density differences became more pronounced. Heavier components began spending more time deeper within the interior, and not because they were directed there, but because motion no longer stopped completely. Earlier, any partial separation could be undone. Cooling would halt movement. Reheating would remix everything again. Now, recovery followed a different pattern. After each disruption, internal motion resumed more quickly. The system did not return to its earlier state. Some internal arrangements reappeared faster than before. Others failed to reform at all. This was not stability, it was continuity. Continuity allowed organization to persist across interruptions. It allowed internal gradients to survive long enough to influence the next phase of change. Sustained internal motion made long-term structure possible, but only gradually. Internal differentiation did not complete itself. It stabilized unevenly. Some regions became more resistant to mixing, while others remained mobile. The interior was not uniform, and it did not need to be. The key change was that internal processes began overlapping in time instead of replacing one another entirely. Cooling no longer erased motion everywhere at once. Heating no longer reset internal structure everywhere at once. As a result, internal organization began to accumulate. not as a single event, but as a pattern that became harder to reverse. Repeated recovery mattered as much as repeated disruption. Each recovery tested whether partial organization could resume under altered conditions. Each time it did, the system retained more of its previous internal state. Energy sources shifted as well. Short bursts became less dominant. Longer-term retention played a greater role. Internal heat became increasingly influenced by the planet's own mass rather than external inputs. This transition was not guaranteed. If recovery had taken longer, internal motion would have ended. If disruption had been stronger, recovery would not have occurred at all. If energy retention had increased too slowly, structure would have remained temporary. What occurred stayed within narrow margins. As mass continued to increase, gravity held internal material more tightly. Heat loss slowed. Motion persisted through longer cooling periods. Differentiation began, lasting across interruptions rather than collapsing afterward. This is where long-term structure becomes possible. Not because the system reached equilibrium, but because it stopped resetting completely. Internal layers were still forming, still shifting, still incomplete. But they no longer vanished entirely after each disruption. The interior began responding as a system with memory. Earlier states influenced later ones. Past arrangements affected how new energy moved through the interior. History mattered. This did not remove uncertainty. It reshaped it. Instead of asking whether internal organization could exist at all, the system now faced a different constraint: whether organization could persist long enough to matter. The answer remained conditional. Some internal boundaries stabilized only temporarily. Others lasted longer but remained vulnerable. No arrangement was permanent. What changed was the balance between loss and retention. Loss still occurred. Mixing still happened. But it no longer erased everything that came before. This gradual shift allowed long-term structure to emerge without ever becoming complete or secure. It did not require calm conditions. It required repeated disturbance followed by recovery within limits. Stability, in this sense, was delayed. It arrived not as a moment, but as a tendency for internal motion to continue, a tendency for differentiation to resume rather than restart, a tendency for structure to persist just slightly longer each time. Nothing about this was inevitable. Growth created the possibility, but possibility alone did not determine the outcome. Only the specific sequence of conditions allowed long-term organization to begin. Without repeated recovery, structure would not have lasted. Without repeated disruption, structure would have frozen too early. Without precise timing, neither process would have supported the other. What emerged was not certainty. It was endurance within narrow physical limits. And with that endurance, the system entered a new phase. One where internal structure could exist long enough to shape what came next, even as uncertainty remained. Conditions compatible with long-term persistence did not appear at once. They emerged gradually after internal and surface processes began operating within narrower ranges. Earlier stages allowed wide variation. Temperatures shifted dramatically. Internal motion stopped and restarted. Surface conditions changed faster than any sustained balance could form. That flexibility narrowed. Internal heat remained present for longer periods, but no longer dominated every process. Cooling slowed without stopping. Motion continued without complete mixing. The interior stayed active, but not chaotic. This balance mattered. When internal motion persisted without constant reset, Material exchange between deep regions and the surface became more consistent. Volatile components were not immediately lost. Heavier elements remained largely contained. Surface conditions responded slowly. Energy arriving from outside no longer overwhelmed internal heat. Instead, both sources contributed within limits. Temperatures fluctuated, but not without bounds. This did not create calm, it created duration. Surface material could remain present long enough to interact repeatedly. Cooling intervals extended. Heating events no longer erased all prior states. These conditions followed disruption. They did not exist before it. Earlier disruptions redistributed material, altered internal structure, and changed how energy moved through the system. Without those changes, surface conditions would have remained either too transient or too extreme. The surface was not stable, it was persistent. Chemical components remained present long enough to undergo repeated interaction. Loss still occurred, but not immediately. Retention increased without becoming complete. Atmospheric material, where present, was vulnerable but not instantly removed. Outgassing followed internal processes that continued over extended timescales. Loss and replenishment overlapped. This overlap mattered. It allowed surface conditions to remain within a narrow range more often than before, not continuously, not reliably, but often enough to matter over long durations. Internal processes supported this persistence indirectly. Continued heat allowed slow recycling of material. Differentiation influenced which components reached the surface and which remained below. None of this guaranteed long-term compatibility. The range was narrow. Slight increases in energy would have driven loss. Slight decreases would have halted internal support. Timing remained critical. Conditions had to persist long enough for feedbacks to operate, but not so long that stagnation occurred. This balance did not settle into a fixed state. It oscillated. Surface environments shifted repeatedly. Internal motion adjusted slowly. Each change altered the next one slightly. What mattered was not any single state, but continuity across change. Habitability in this context was not a property, it was a constraint. A constraint defined by temperature ranges, material retention, and internal activity that remained neither too weak nor too strong. These conditions were maintained only because earlier disruptions reshaped internal structure and energy flow. Without that history, surface persistence would not have occurred. This stage was not an endpoint. It did not represent completion. It did not resolve uncertainty. Conditions remained vulnerable. Loss was still possible. Internal motion could still decline. External events could still alter everything. What changed was the timescale. Processes now operated long enough to interact repeatedly rather than briefly. Surface states could influence internal responses over time. Internal changes could affect surface conditions gradually. This interaction created continuity without certainty. The planet did not become secure, it became sustained. That distinction matters. Sustained conditions allow complexity to persist without guaranteeing it. They allow processes to build on previous states without ensuring permanence. At this stage, nothing was finished, but the range of possible outcomes narrowed again. Extreme states became less frequent. Moderate conditions occurred more often. Persistence became possible, but never assured. This is where appreciation deepens, not because the outcome was favorable, but because the conditions remained balanced within limits that could easily have been exceeded.
To listen.
Existence rested on duration, not stability. and duration here was always provisional. What follows does not describe arrival, it describes continuation under constraint and the quiet dependence of what came next on how narrow those limits remained. Survival did not depend on strength, it depended on balance. At every earlier stage, small differences would have changed the outcome, not dramatic shifts, not extreme events, minor deviations occurring quietly long before any lasting structure was established. If material had dispersed slightly faster, accumulation would not have continued. If internal heat had escaped more efficiently, motion would have ended early. If energy input had arrived in different intervals, internal rearrangement would have stalled or reversed. None of these differences would have been obvious at the time. They would not have announced themselves as turning points. They would simply have altered the range of what could continue. The early system operated within limits that were narrow from the beginning. As mass increased, those limits changed, but they never widened enough to allow safety. Balance remained conditional. Too much internal heat would have driven loss faster than retention. Too little would have prevented long-term motion. Retention without motion would have led to early stagnation. Motion without retention would have led to gradual depletion. Continuation required overlap. Processes had to operate together, not in sequence. Heating and cooling, loss and replenishment, differentiation and mixing. None could dominate for long without ending development. Earlier disruptions shaped this balance without stabilizing it. They adjusted internal pathways just enough to keep motion going without fixing any outcome. As time passed, sensitivity did not disappear. It shifted. Later stages depended on the cumulative effects of earlier ones. Small changes no longer reset everything, but they still mattered. They altered rates. They changed thresholds. A slight reduction in internal heat production would have shortened active periods. A slight increase in external loss would have reduced surface persistence. A small difference in internal composition would have altered how energy moved outward. None of these differences required catastrophe. They required only variation. The system did not survive because it became robust. It survived because it remained within a narrow range where opposing processes countered each other without resolving. That range was never wide. Even after sustained conditions became possible, continuation remained dependent on timing and proportion. Processes overlapped just enough. Durations extended just far enough. There was no margin to spare. This becomes clear only when earlier stages are viewed together. Accumulation without retention would have ended growth. Retention without differentiation would have halted internal motion. Differentiation without regulation would have led to instability. Regulation without replenishment would have resulted in gradual loss. Each stage relied on the incomplete resolution of the previous one. No step closed the system. It remained open to change, but constrained by limits established over time. This is where understanding replaces tension. Not because uncertainty disappears, but because its role becomes clear. Uncertainty did not threaten existence at random. It defined the conditions under which existence could continue at all. Small deviations mattered because the system operated close to thresholds. Balance was maintained not by resistance, but by alignment. Alignment between internal activity and external conditions. Alignment between energy input and loss. Alignment between motion and structure. These alignments were temporary. They persisted only as long as conditions allowed. Continuation did not occur because failure was avoided. It occurred because failure remained incomplete. This is the quiet realization at the center of the story. Existence was not secured early. It was not protected. It was not reinforced. It was permitted, moment by moment, as long as balance is held. Earlier uncertainty was not erased by later development. It was compressed. The range of outcomes narrowed, but never closed. The planet did not become safe. It became ongoing. Stability, in the sense familiar today, was not present for most of this history. What existed instead was persistence under constraint, and that persistence depended on limits that could easily have been crossed. This recognition does not lead to reassurance, it leads to awareness, because the conditions that allowed continuation were not permanent features. They emerged late, after long periods of adjustment, and they remain subject to change. What appears stable now rests on a foundation built through repeated narrowing of possibility. Understanding this does not diminish the present. It clarifies it. It shows that what exists today is not the result of strength or inevitability or endurance alone. It is the result of balance maintained across change. As the story moves forward, attention shifts away from early formation and toward the present state, not as a conclusion, but as a reminder that stability is recent, when still ongoing, and that continuation has always depended on remaining within limits. The stability we recognize today is a thin crust atop 4.5 billion years of thermal and structural evolution. If the history of this planet were compressed into a single day, the chaos of the Hadean and the catastrophic impact of Theia would occupy the early morning hours, while the permanent continents and breathable atmosphere we rely on would not emerge until the late afternoon. What exists now appears stable. The surface holds its form. Internal motion continues quietly. Conditions remain within ranges that allow long durations without abrupt change. From a human timescale, this feels permanent. From deep time, it is recent. The balance that now defines Earth emerged after long periods of adjustment. It followed countless intervals of instability, interruption, and partial recovery. Only after those stages did sustained conditions become common rather than rare. Even now, stability is not absolute. Internal heat continues to decline slowly. Surface conditions respond to gradual shifts. External influences still arrive, though less frequently than before. The processes that shaped early formation did not stop. They changed pace. What differs is duration. Conditions now persist long enough to be measured, are recorded and understood. Patterns repeat. Variations fall within predictable ranges. Change occurs, but not without continuity. This continuity allowed awareness to emerge, not as a separate force, but as another outcome of long-term persistence. Observation depends on duration. Prediction depends on patterns. Response depends on understanding those patterns across time. Human awareness did not interrupt planetary processes, it arose within them. The same physical limits that allowed sustained conditions also allowed memory, measurement, and anticipation. The ability to look back at formation and forward towards change rests on the same balance that allowed surface persistence in the first place. This awareness does not alter the underlying rules. Energy still moves according to constraints. Unimaterial still responds to forces without intention. Stability remains conditional. What changes is perspective. Understanding replaces surprise. Knowledge replaces uncertainty. Not by removing fragility, but by recognizing it clearly. The present state of Earth is not a finished condition. It is a phase defined by balance that has held long enough to become familiar. That familiarity can obscure how narrow the margins remain. Internal processes continue at scales beyond direct perception. External conditions shift slowly, but not indefinitely. The same requirement that applied during formation still applies now. Balance must be maintained within limits. Observation allows those limits to be identified. Measurement allows trends to be recognized before thresholds are crossed. Response becomes possible because continuity exists. This is not control. It is participation within constraint. There is no separation between past formation and present awareness. Both belong to the same sequence of physical processes extended across different timescales. Early formation depended on narrow balances without awareness. Present stability depends on narrow balances with awareness. The difference is not privilege, it is responsibility rooted in understanding. Not responsibility as obligation, not urgency, not alarm. Responsibility as alignment with reality. Knowing that stability is recent does not make it fragile in an emotional sense. It makes it specific. It places the present within a longer continuum rather than above it. Nothing has been completed. Internal motion continues. Surface conditions evolve. External influences persist. The processes that shaped the early planet remain active, though subdued. Awareness allows those processes to be tracked rather than feared. Prediction does not guarantee safety. It clarifies risk. Understanding does not prevent change. It contextualizes it. This quiet clarity is the natural extension of the story. From unresolved accumulation to conditional persistence to sustained balance to awareness within continuity. No single moment defines this transition. It unfolds gradually as stability extends long enough to be recognized. The planet did not arrive at a final state. It entered a long interval where change occurs slowly enough to be observed. That interval continues now, and within it, understanding does not stand apart from physical history. It remains embedded within it, shaped by the same constraints that shaped everything before. Nothing here requires urgency. Nothing demands action framed by fear. Awareness itself is the outcome, the knowledge that stability is not guaranteed, yet persists within limits. The recognition that continuation depends on balance rather than permanence. This understanding allows rest, not because nothing will change, but because change has always occurred and continues within knowable bounds. The present moment belongs to the same ongoing process that once held formation in uncertainty. The difference is that now, continuity has lasted long enough to be felt as calm. That calm is not separate from fragility, it is defined by it, and in recognizing that, the story does not end with warning or instruction. It settles into the awareness that Earth's current state exists within ongoing processes shaped by balance, sustained by limits, and continuing quietly, without finality.